I made a transistor controlled nightlight. I'll show you how I did it. So the circuit that I use consists of a voltage divider that has a 20K resistor and a light dependent resistor, and when you hook them up as shown here, in between the two resistors it acts as a voltage divider. That voltage divider output then goes to the base of a transistor, and then on the collector side of the transistor is an LED in series with a current limiting resistor, and then the emitter of the transistor is just connected to ground. And so what happens is, as the amount of ambient light in the room decreases, that is, it gets darker, then the resistance of the LDR increases, thereby increasing the voltage output from the voltage divider that goes into the base of the transistor, and that turns the transistor on. And when the transistor is on, then current flows through the LED and it makes light. So on the left here is a breadboard model that I made of the circuit. So here's the light dependent resistor here, here's the transistor, here's the other side of the voltage divider. So you can see the output from the voltage divider follows this white wire here into the base of the transistor, and then the emitter side of the transistor is connected to ground, and then the collector side of the transistor is attached to the LED, which is in turn attached to the current limiting resistor. So I got all that to work. And then I transferred the design to a perma proto board where I could solder everything. And so this picture on the right here is partway through that process where I was putting all the components in place and making sure there was room for everything. Here's the Autodesk Fusion model of the Nightlight, and so I designed and printed an enclosure for it, this box here, and then I modeled the perma proto board. I modeled the DC power jack so I could get the hole in the case in the right place. Down here I put in the LED and the light dependent resistor and put them in position just so I could measure how long the wires needed to be to get everything to fit. And then here's what it looks like in the operating position. When I printed the enclosure, here's what it looks like in Prusa Slicer, the slicing software I use to run my printer. It took about 80 minutes to print and used about 13.5 grams of filament. And I think it was about 83,000 lines of G-code to make this thing. The flower's pretty interesting. So one of the websites that I use for getting 3D models is called Printables. This is a website from Prusa that made my printer. And so a guy designed some roses, and it's interesting. Here's what the STL model of the flower looks like, but what you do is you put it in what's called vase mode in the slicer. And so vase mode is a setting that creates three-dimensional objects by continuously extruding filament in a single upward spiral rather than the discrete layers that are usual for 3D printing. So it's a single wall and is therefore very, very thin and translucent, but also very fragile. But it looks really cool, and it's perfect for this application. So here's what it looks like when it's all done. So the flower is attached to the top of the base, and then you can see the LED down at the bottom of the flower, and then here's the light dependent resistor. And you might think, well, gosh, how can the LDR work if it's right next to the LED? And the answer is the LDR is above the LED, and so it's the top surface of the LDR that's sensitive to light. So the top of the LDR isn't getting the light from the LED. The LDR is getting light from the ambient light in the room. Okay, so that all works. And then here's the underside of the case that has the perma-proto board and the power supply and all that, and it's screwed into the base that I printed. Okay, so that's what it looks like. So kind of a cool project. It doesn't have any code. You know, the programming language is solder, and it just relies on some kind of cool physics here, electrophysics with a voltage divider and a transistor and just a simple LED and some simple math here to figure out what the resistor values need to be. All right, transistor controlled nightlight.